So let's start section 9.5, and our goal is going to be to use formulas to solve problems, solve a formula or equation for one of the variables. That's something you're going to have to work on. It always seems to be a problem. And of course the key vocabulary is a formula. So let me tell you what a formula is. A formula is basically an equation with all variables. Where each variable stands for a known quantity of some form. Many times those quantities are measurements, but sometimes they're not. It just depends on the different formula. So we'll look at an example of a formula. And right here, in example 1a, we have a formula given as D is equal to RT. So that's a formula. It's an equation with all variables, but you have to know what this formula is for and what the variables stand for. In this case, they're all measurements. D stands for distance. R stands for rate of travel. In this case, we mean by that speed. And T stands for time. And in this case, our time is usually going to be in hours. But the time element is dictated by our rate. So example, if your speed is miles per hour, then your time is in hours. If your speed is kilometers per second, then the distance is in kilometers and the time is in seconds. So in this case, we're going to use D is equal to RT, and we're going to be given that our time variable T is 9, and that our distance is equal to 63. So let's plug those in. So D is equal to 63, and my time, which I'm going to put first, since this is multiplication, it doesn't matter at all which of the two I put first. So my time is going to be 9, and R is my unknown. So basically, I'm going to use the formula. I'm given all values but one. And in this case, the one that I'm not given is the value of R, and that's what I'm going to solve for. So just like always, 63 is equal to 9R. So I multiply both sides by 1/9, which is the multiplicative inverse of the coefficient of my unknown. It's the same as dividing by 9, both sides. It's a little bit more space here. Maybe even do this. And that gives us 63 divided by 9 is 7. 9 divided by 9 is 1 times R is R. So in this case, our rate is 7. Now, notice in this particular formula, it's kind of too simple for you. They should literally give you some units, but since you're just starting, they don't give you units. So 7 is our rate, but we don't know, is that 7 miles per hour? Is that 7 kilometers per second? So in real life, they would have done something like this. I discovered how to, I discovered how to erase with the big eraser. I'm so happy. So in real life, they would have said something like our distance is equal to 7 miles. And our rate is equal to 63 miles per hour. In which case, sorry, I did that wrong. Let me go back to my eraser. Rate is what we just solved for. They gave us, let me just start all over with this part over here. Sorry about that. No, we don't want to see that. Start all over. So our distance, normally they would say, would be 63 miles. And our time would be 9 hours. And then our rate would be 7 miles per hour. So if our distance were 63 kilometers and our time were 9 seconds, then this would change to 7 kilometers per second. So that's kind of what they're hiding there for you. But I just wanted to show you that. And as you advance mathematically, they will actually give you the variable value along with the corresponding unit. 63, not just plain 63, but 63 miles. Time, not just plain t is equal to 9, but 9 hours. So let's do the next one. So perimeter of a rectangle. So if you have a rectangle, so here is the best I can draw. The perimeter is the total distance that you have to walk around its edge. So if this is the length and this is the width, then this side over here is also the same as the width, and this side up here also has the same length as the bottom. So the formula for the perimeter is width plus length plus length, which is equal to 2w plus 2l, or as they give it up here, 2l plus 2w. They're identical. Why? Because I'm adding, in addition, shares the commutative property. It doesn't matter which order. So that they're going to give you, our perimeter is 32. So let's just go ahead and pretend that's 32 inches. I'm going to go ahead and add some units here, although they don't. And our width is equal to 7 inches. They have to be the same unit. Well, they don't have to be, but in order to add them, they have to be. So we want to find our length L. So really what I want to do is I want to find L is the one variable that is unknown, so L is my unknown. So the perimeter is 32 is equal to 2L plus 2W. But I've been given the value of W is 7. So I'm going to go ahead and simplify on my next step. 2L, I can't do anything with that yet, but 2 times 7 is equal to 14. So here, let me make this a little bit bigger. Maybe you'd like to kind of see some of the stuff I have up here. So Here, what I want to do is I want to isolate L on one side of the equation by itself. So I subtract 14 from each side, or I move what is equivalent, this term here, to the other side. And what happens? What's our rule when we move a term to the other side of an equal sign? It changes sign. So that's 32 minus 14 is equal to 2L. And 32 minus 14 is equal to 18. And 18 is equal to 2L. So now what do? I know what 2L is. So I want to know what 1L is. So I divide both sides by 2, which is exactly the same as multiplying both sides by the reciprocal of 2. Remember, the reciprocal of 2 is 1/2. So that's going to give me 18 divided by 2 is 9, and 2 divided by 2 is 1 times L is 1. So L is equal to 9 inches. So L, we actually now know, is equal to 9 inches. Okay, not so bad. So let's go on and let's look at the next problem. So here is the volume of a pyramid. So I'm pretty sure pyramids come in two different forms, and you know how bad I am at drawing, but I'm pretty sure that this is a pyramid of a three-sided pyramid. So the bottom is going to be a triangle, and you're going to have some apex here, and that's, let me try to draw this over again, just kind of you can see what's going on and understand what the volume is. So draw another pyramid, another triangle. I'm going to put the top of the pyramid here, so it has a side that goes down to that corner, and to this corner down here. So that's my pyramid. And the volume, if you wanted to fill this with sand or rocks or dirt, the volume is how much you would fill inside there. So you all can draw better pictures than me, I'm sure. But the volume is given to 1/3 times the base length times the height. So if I'm looking at the pyramid from directly front on, this length right here on the bottom is the base length. And the height simply is how high it is in the air. How far the apex is at the very, very tip top to the bottom. That's the height. So in this particular question, we're given the volume. The volume is equal to 40, and we'll pretend that's 40 feet. And the height is equal to 8 feet. I'm just adding units just to make it meaningful in real life. And what is the value that we are not given? We're not given B. B is our unknown. That's what we want to find out. So let's solve for it. So I replace B with 40. My base is my unknown, and my height is 8. So this is the same as 40 is equal to, because this is one factor, 1/3, times my unknown value B times 8. That's just multiplication. So again, I can change the order of factors in multiplication in any way I want, and I want to. I want to say this is 8 times 1/3 times b, which is precisely the same as 40 is equal to 8 divided by 3 times b. So I want to solve for b. So what do? I look at the coefficient of b. It's 8/3. So I multiply both sides by its reciprocal. And what is the reciprocal of 8/3? You just flip the fraction over. Or if you want, you can use cross multiplication and do it in 2 steps. It means I'm going to multiply the 3 up here and the 8 down here. I always like cross multiplying because I used it an awful lot when I was learning math. So by multiplying the 3 up here, I get 40 times 3 in the numerator, and the 8 multiplied down times 1 is equal to 8, is equal to b. So let's simplify this. 40 times 3 is 120, and 120 divided by 8 is my b value. And when I do that math, I get a b value of 15, which in this case is 15 feet. So we have time. Let's go ahead and go back up to our original equation. 40 is equal to 8/3 b. I'm going to show you another way to do that. So we had 40 is equal to 8/3 times b. Now notice the reciprocal of my unknown, which is b, is 8/3. So what did I tell you to do? You multiply both sides by the reciprocal of 8/3, which is 3/8. So I'm going to multiply this times 3/8, both sides, and this times 3/8, both sides. So 3, the 3's cancel, the 8's cancel. So that leaves me with a single b over here. And over here, I just multiply 3 times 40 over 8, which gives me 120 over 8. All of that is equal to b. And as we just discovered, that gives me a value of b is equal to 15 feet. So just exactly the same problem, done a different way. The next one is a really good problem as well. It's the calculation of simple interest. So when you get a credit card, or you take out a loan, or you invest money in a bank, etc., simple interest sometimes plays a role. There's a lot of different types of interest. There's interest compounded weekly, monthly, quarterly, daily, continuously. And when you actually get to, if you're going that route, if you get to college algebra, we'll actually derive the formula for continuously compounded interest. And that's always the best. You always get more money that way. But this is just simple interest. It's just compounded once, in other words. So I, in this case, this is the formula. I is equal to P times R times T. So this is our formula. But you have to know what the variables, formula, you have to know what the variables stand for. I stands for the amount of interest earned. At the end of 1 year, in this case. P, sometimes they use an uppercase P, here they're using a lowercase p, stands for the principal. And that means the original amount you invest, or you put in a savings account, etc. It's always called the principal, even on a car loan. And R is the interest rate. Many times this is given in a percentage, for example, 2%. And what do? We have to convert it to a formula, to a number, and that's equivalent to 2 over 100, which you all should know by now is the same as 0 tenths place, hundredths place, right there. So here we're given that my interest is 23, so this will be dollars. My principal is $230, and my rate is 0.02. What is our unknown? Our unknown is time. They want to know if I earn $23 in interest, how much time do I have to have it invested? And in this case, time, and I forgot to write that down, time, T stands for time, and it's always, I've never seen it in any other way other than years, at least in problems in mathematics. I don't know about the real world. So we're going to solve for T. So again, what we're going to do is, I think it's going to be easier for us to write 0.02 as 2 over 100. So remember, this is tenths, this is hundreds, so this is 2 hundredths or 2%. Let's give ourselves some more room. So now we've got to multiply these two together. So I have 20 is equal to 460, because to multiply two fractions, you multiply the numerators and then the denominators. So 230 times 2 is 460, divided by 100 times T. And if you want, and I absolutely am fine with it, you can solve this by cross-multiplying. And to cross-multiply, sometimes it's easier to make our 20 into a fraction by putting it over 1. So I take my 100 and I multiply it up to the numerator, and my 460 and I multiply it down to the denominator. So my numerator becomes 20 times 100. My denominator becomes 1 times 460. And that is equal to T, and T is going to be in years. So we need to do some simplification here. So 20 times 100 is 2000. So I add 2 zeros to my 20. And then I'm dividing it by 460. And that's equal to T. So my dad always says 2000 instead of 2000. It's just something that generation, I think. So now we can simplify by dividing both sides by 10, which is equivalent of just getting rid of those 2 zeros. These are skills we learned in 0018. So it's 200 divided by 46, which is equal to T. And that actually turns out to be, when we do the math, whoops, hit the wrong icon. That turns out to be T is equal to 5, and T is given in years. So let's go back and think about this. If you invest something at for using simple interest, and you invest $230 at a 2% interest rate, which is less than a lot of banks will give you for savings accounts, which is, more than most banks will give you for savings accounts, after leaving it in for 5 years, you're just going to earn $23. Kind of nice to know when you're thinking about investing. That's the reason lots of people invest in stocks and take the gamble, because many times stock investments yield much higher rates of return. At the same time, they could crash just like they did now. So it's an interesting calculation, and there's a whole mathematics of economy that mathematicians try to do. It's very complicated, thousands and thousands of unknowns, and trying to gain the markets or predict the markets. They're never able to predict the markets because it's known that markets are chaotic systems. And if you take me in another class, I'll probably at some point explain mathematically what a chaotic system is. So here we're asked to convert the record high temperature from 102 degrees Fahrenheit to Celsius. So there's two types of temperature measurement. The one we use, which is Fahrenheit. How do you spell Fahrenheit? Fahrenheit. It's a German word. I'm going to guess it's spelled that way. And the other to Celsius. Most of the world uses Celsius. England, United States, maybe Australia, I'm not for sure. And to be honest with you, I don't know that England uses Fahrenheit. We literally may be one of the few major countries that still uses Fahrenheit. But if you ever travel, for example, when I lived in Tucson, that's Arizona desert, sometimes we get a temperature of around 100 degrees, 115 degrees in the summer. And when I was visiting Latin American friends, I wanted to tell them just how hot it was in Tucson, so I had to use the formula, and I'm doing this by memory, not by calculation. I would tell them that it would get up to 43 degrees Celsius where I lived, and they would look at me like I was crazy because that's ungodly hot for them. At any rate, we have a formula to convert, given the degrees in Celsius. This formula here converts those degrees in Celsius to Fahrenheit. So F stands for degrees Fahrenheit, C stands for degrees Celsius. So the variable F stands for a measurement of temperature using the Fahrenheit scale. C stands for a measurement of temperature in Fahrenheit. Oops, I erased more than I wanted to, but you all have memories so you can remember what I just wrote there. So we are given that we have a temperature measurement of 102 degrees F, and we want to know how much that measurement is in degrees Celsius. This little circle right here is just shorthand for degrees. It's also used in angle measurement, and we've co-opted it for temperature measurement as well. So this is study this problem. This is a really important problem, because I guarantee you it will be on your exam. And it is one of the most missed problems at this point. So we're given that F is 102 degrees Fahrenheit. And we don't have to write degrees Fahrenheit. And I want to find out how much that is in Celsius. So basically I have to solve this equation right here for the variable C. So the first thing we always do when we're trying to solve for a specific variable is we isolate that variable and its coefficient. In this case, its coefficient is 9/5 on one side of the equation. So that means I'm going to move this term plus 32 over to this side. And what's the price we pay when we move a term across the equal sign? It has to change signs. So 102 minus 32 is 70. So I have 70 is equal to 9/5 C. So let's solve for C. Let's use cross multiplication again. So I'm going to put 70 over 1, and I'm going to multiply the 5 up here and the 9 down to there. So that leaves me C all by itself. That's what I want on the right-hand side of the equation. This is 70 times 5 divided by 9 times 1. So over here, that's 350, which is 70 times 5, divided by 9. And when I do that, that turns out to be about 38.9. So our answer is 38.9 degrees Celsius is equal to 102 degrees Fahrenheit. And that makes sense because I just said, well, 115 degrees Fahrenheit was about equal to 43 degrees Celsius. So my memory may not have been so bad after all. So let's do the next problem. Whoops, don't mean to do that. So in this one, you've decided to fence an area of your backyard for your dog. Happens all the time. My brother's doing it right now, and then their dog died. The length of the area is 1 meter less than twice the width. If the perimeter of the area is 70 meters, find the length and width of the rectangular area. So let's start out with the picture if we want. So here's going to be my rectangular area. This is going to be my length, and this is going to be my width. And we have to use the equation for perimeter. So perimeter is equal to 2L plus 2W. So the length of the area, you've decided to fence an area of your backyard. The length of the area is 1 meter less than twice the width. So what they're saying here is that twice the width, I don't like the way it's worded, minus 1 is equal to L. So this is really bad. They should simply say the length is 1 meter less than twice the width. And they say the length of the area is 1 meter less than twice the width. Really bad English there because we're calculating perimeter, but area is something altogether different that we could also calculate from this. You all might not notice it, but this clearly should say the length is 1 meter less than twice the width. The length of the rectangle. At any rate, the length of the length is twice the width minus 1. If the perimeter is 70 meters, find the length and width of the rectangle. So we're given that the perimeter is 70. and that's 2 times L. But over here, I find that L is equal to 2W minus 1. So I have to multiply L times 2W minus 1. And then I just add the 2W term right there. And now I have an equation and I can solve it. It's an equation in the variable W. So 70 is equal to, I'm going to use distribution here. 2 times 2W is 4W. 2 times minus 1 is minus 2 plus 23. So now I just collect like terms on the right-hand side and simplify. Minus 2 plus 23 is plus 21. That's the same as 23 minus 2. So now I'm going to take this term, plus 21, and move it to the other side. Let me give myself some room here. And when I do that, it becomes negative. So 70 minus 21 is equal to 4W. So 70 minus 21 is equal to 49 is equal to 4W. Did I do something wrong? Ah, sorry. I've done something wrong. Did anyone catch it? Let's go back. I'm hoping you know what I did wrong and you're waiting. Okay, eventually. I forgot to multiply W by 23. So the length is 2W minus 2. Where am I getting the 23? Oh, my goodness. Sorry, people. Somehow, in my mind, I changed W into a 3. So yes, it happens even when I'm not in front of a class. So that's supposed to be W, not 23. Magically turned to 23 over me. Now we're good to go. Very good to go. So again, point is, so I'm going to make this really clear. I don't know a mathematician out there that doesn't make mistakes. So we're going to start all over, starting right there. The point is that you catch your mistake. No one can be expected to do things without ever making errors. It's normal, and to pretend that people don't, well, they're lying to you because they always do. And I don't know why they would even bother to lie. Just be honest about things. It's so much better. Now if I can turn off my... Ooh, don't want that. Now it does it. There we go. Do I? Yeah, I've got my pin back. So let's start right here. So I have 70 is equal to, again, I'm going to use distribution. The cool thing about this is if you see me make a mistake, you can fast forward. So 2 times 2W is 4W, and 2 times minus 1 is minus 2, and that's plus 2W. W. So let's actually collect terms on the right-hand side first. And 4W plus 2W is 6W. And then I'm subtracting that from 2. Now I'm going to move 2, this term right here, the minus 2 rather, to the other side. When I move it to the other side, it becomes positive. So I add it to 70. Yeah, it's getting out a lot better now, right? Yeah, these problems at your level are really simple. We try to avoid fractions. So we have 72 is equal to 6W. And you can solve this by cross multiplication too. If you want, just make both of them fractions and multiply the 6 down to the bottom. At any rate, you get 72 divided by 6 is equal to W. So 12 is equal to W. So the width is 12. We'll just say it's inches. They don't tell. No, it's feet. It doesn't say. We'll just pretend it's feet, but if you want to, you can pretend it's yards. So 12 is equal to W. So I'm going to use this equation right here. I'm going to use this equation right here to find the length. So I've got the W. The W is equal to 12. We'll say 12 yards. Why not? So the length is twice W, which is 12, minus 1, which is equal to 24 minus 1, which is equal to 23. So the length is 23 yards. So again, if you were to draw a little picture, the width is 12 yards and the length is 23. And you don't have to draw that picture. Okay, let's do another problem. Get us some more working clear space. And let's go to the next page. So this might be one you might want to try on your own. So for the holidays, Chris and Alicia drove 476 miles. They left their house at 7 a.m. and arrived at their destination at 4 p.m. They stopped for 1 hour to rest and refuel. What was their average rate of speed? So remember, D is equal to RT. Distance is equal to rate times time. And I told you earlier that rate is the same as speed. This is the equation we use. So we have to figure out, what are we given? We're given that the distance is equal to 476 total miles. We're asked to find their average speed, which is just another way of solving for R. So we've got to figure out the time, though, the total travel time. So they left their house at 7 a.m. and arrived at their destination at 4 p.m. But they stopped for 1 hour to rest and refuel. So their actual travel time from 7 a.m. to 12 to noon is 5 hours. And then they drove another 4 to get, then we go to 4 p.m. So that's 5 plus 4 hours. But then we have to subtract from that 1 hour for the rest. So that's 9 minus 1. So they actually drove for 8 total hours. So distance is 476. Their time is 8 hours, and we want to solve for t. This is pretty easy. Again, you can do it by cross multiplication if you want. We multiply down. So 476 divided by 8 is equal to the time. Sorry, I made another mistake. My variable is my r. I entered the t. My variable is my r. So that is my rate of travel, that's my speed, and that's about equal to 59. Once you divide 476 by 8, it's about 59.5 miles per hour. Let's do another one. So here is the point where it's really important you know how to do this. And this, unfortunately, is the part where, I don't know, I think it's just because you're beginning students. But beginning students always have problems with this. So in this case, I'm not going to give you any specific values of anything at all. So I'm just going to give you a formula. So in this case, the formula is the area of a triangle. The area is equal to 1/2 times base times height. And notice you don't even know that you don't have to know that A stands for area. You don't have to know that B stands for base. And you don't have to know that H stands for height. This is just a formula. We know that A stands for some quantity, B stands for another quantity, and H stands for yet another quantity. So given that formula, we're asked to solve for the variable B. So B is kind of like our unknown. So B is acting like our unknown value X here. And if you want to replace B with X, if that helps you, absolutely can. So the first thing I'm going to do is, this is a fractional equation. It's an equation with a fraction. So I want to clear that fraction out. So what do is I find what the denominator is. It's 2. And I want to multiply both sides by the LCD of the denominators, but there's only one denominator, so the LCD is just 2. So I'm going to multiply both sides by 2. You could also do this by cross multiplication. And now when I simplify this, I'm going to get 2a, and 2 times 1/2 times b times h is the same as 2 divided by 2, which is 1, times 1 times b times h. So this just becomes b times h. So that whole process that we just did by multiplying both sides by the LCD of the denominator is called clearing denominators. And the end result is always that you get an equivalent equation without any fractions at all. I just got rid of the fractions. So what are we going to do? We're asked to solve for b, so I treat my b as my unknown. So in order to get b by itself, I divide both sides by the other variable, which is h. Or if you want, we'll come over here and we'll do it the cross-multiplying way. So I want my b to stay here, so I take my h and I multiply it down there. The end result is 2a divided by h, B times H divided by H is equal to B. And the important thing is, this is valid. This is another formula. Two A divided by H is equal to B. And you've now solved the original formula, A is equal to 1/2 B times H, for B. B is equal to 2 times A divided by H. This is a very, very important skill. I use it all the time. Probably if I were to seriously, before I became a math grad student, because things changed enormously then, but before I actually went back into math, solving formulas for specific values was one of the most used skills that I ever used in math. So here we're going to have a triangle. So the perimeter of a triangle is how far you would have to walk, or the distance if I start at one vertex and walk all the way around, staying on the edges. That's that total distance. So I'm going to call this distance of this side S1, and that stands for the distance of side 1. The distance for side 2 I'm going to call S2, and the distance for side 3 I'm going to call S3. So clearly the perimeter P is equal to S1 plus S2 plus S3, where S1 is the length of side 1, S2 is the length of side 2, and S3 is the length of side 3. So we're asked to solve that formula for S1. So I'm going to come up over here in this space I have. P is equal to S1 plus S2 plus S3. And I want to solve for S1. That's what I want to have all on one side by itself. Well, this is really easy. I'm going to take S2 and I'm going to move it to the other side. What's the price I have to pay? It becomes negative. Or, sorry, the sign changes. It actually would become negative because these links are always positive. Well, I'm almost there. I want S1 by itself. So I'm going to repeat the process and take S3 and move it over there as well. So my P minus S2 stays over there, but it's joined by minus S3. And finally, I have S1 on a side by itself. So this is the formula for the perimeter of three sides, which basically says if I know the perimeter length, and I know the distance of S2 and the distance of S3, then I can also know the distance of S1. So I think that is it for what we're going to do in section 9.5. And again, if you have questions, just send me an email and I'll be happy to answer them. So just keep studying and stay safe.